Hello and welcome to our presentation on the Digital Mental Health Literacy Hub. This project, created by our team foreman, focuses on enhancing mental health literacy for higher education students using the Agile software development principle. So let's get started. Let me introduce our team. My name is Ao Yihao. Joining me are Chu Zoheng, Go Changze, and Chong Yun Chuan. This SD describes the development and implementation of the Digital Mental Health Literacy Hub, a system designed to enhance mental health literacy and provide accessible, stigma-free support for higher education students. It outlines the system functionality, technical architecture, and testing framework to ensure it meets user needs and project goals. The SD is intended for the stakeholder, including developers, designer, tester, project manager, mental health professional, and administrator staff to facilitate effective collaboration and successful system deployment. For the scope of our project, the hub offers self-assessment tools, educational module, peer forums, personalized recommendation, and telehealth option. It is not a replacement for medical diagnosis, but complement existing mental health service. Our goal is to foster a supportive campus environment, reduce stigma, and improve academic performance. So for our SD documentation, provide a detailed breakdown of the hub purpose, scope, design, and testing. It ensures clarity of all stakeholders and highlight how the system addresses the unique challenge of higher education students. Now, let's look at our personas. The first persona is higher education student. They need tools to manage their mental health, such as educational modules, self-assessment, peer forums, telehealth service, and self-care guides. These features are designed to help students proactively care for their mental well-being. Next, we have faculty members. They need resources to better support students, tools to report concerns to mental health professionals, and ways to encourage students to use the hub independently. For administrative staff, the focus is on managing the system security, monitoring engagement, and analyzing data trends. This capability help institutions improve their mental health initiative and make informed decisions. Lastly, for the Persona 4, mental health professionals, they require tools for virtual consultation, tracking student cases, and analyzing anonymized data. These features support better care strategies and research into mental health trends. Next, specific requirement. This is the use case diagram for our system. The diagram shows how various users, including students, faculty members, administrative staff, and mental health professionals interact with the system. There are several key modules such as education module, self-care tools, peer support, virtual support, analytic and reporting, faculty training, and resource. The system ensures seamless collaboration and robust data security while fostering an inclusive environment for mental health support.
Good morning, everyone. My name is Chong Guan. Now, I'm going to talking about the domain models of our system. So, for these domain models, we have 6 domains that we should focus on building our system. The first one is users, and second one is mental health resource, assessment result, subcase 2, peer forum, the last one is analytic report. So, this model is defined the several key classes and along with their attributes and the relationship. So, I will explain the relationship and list up one of the example of the relationship in this domain class. So, for example, the users can more than one users can access many mental health resources, which showing the relationship between the users and the mental health resources is many to many. Okay, next, I will explain about the step diagram of our system. So, the step diagram illustrates the transition between system steps such as logging, accessing resources, and viewing the results. So you can see all the features of this step diagram are accessed by several different users. So for the examples, for browsing, this feature is only open for 3 users, such as students, a faculty member, and mental health professor, while the assessment engagement is only accessed by the administrative staff. So to see the student engagement in the system. So for the next part, I will discuss about the launch phase of our project. So before this, what is the product backlog? So it's a prioritized list of features and requirements for the digital mental health literacy hub. And the, the product backlog has provided several features like self-assessment, peer forum, and analytic dashboards. So for this example, the second module of the product backlog is self-care tool. It allows users to set wellness goal and offer a guide tool for self-care. After talking about the product backlog, now I'm sharing with you the spring backlog of our system. So each spring focus on delivering specific functionalities. For example, the spring one is focused on education module. So as a user, I want to access mental health literacy resource so I can learn about self-care and the mental health topic. So this is on by users named students and the faculty members. So for the next sprint is focused on self-care tool and peer support. So the scenario is As a user, I want to set a wellness goal to track my progress in improving the mental health. This sprint are involving the interaction between the student and the faculty members. And the team member assigned for this sprint is developer and the data engineers.
Hi, Dr. Lukman. My name is Guo Changze, and today I will explain the system requirement in our project, focusing on use case description, activity diagram, and the sequence diagram. Use case description specifying actors, pre-post condition, and the flow of event, alternative and exception flow. Activity diagram represents workflow, showcasing the sequence of action, transition, and behavior. Sequence diagram focus on interaction between the system components over time, emphasizing message exchange. To illustrate this, I will highlight a few key use cases, explaining the feature they offer, the underlying step, pre-post condition, transition, and message exchange. This is one of the use cases in our project, which is assess mental health literacy. Here's the use case description. The actor is UTM student, and it described as a student, they shall be able to access educational resource on mental health topic, including interactive video, article, and quizzes. The precondition to get access to this feature is the user should be logged in and authenticated, and the flow of the event outline the step for accessing mental health literacy content, from selecting the feature on the dashboard to viewing personalized recommendation and additional resource like self-care tools and peer support. Post condition after finishing the following steps in the flow of event is the user able to gain knowledge, recommendation, and the data is stored. The alternative flow address scenarios like navigating to other pages or leaving the system, while exception flow handles situations such as selecting severe content, prompting emergency resources, or connectivity issues, where the system ensures user guidance. This is the activity diagram of the use case, and it shows the collection of behavior and transition between the steps inside this use case. In this sequence diagram of access mental health literacy, it shows the interaction between the actor, which is the UTM student, and the objects such as menu page, category page, showing their behavior within the system. For example, the student can choose the category on the category page, which shows the interaction between the actor and the object. And noted that below the graph, there is an alternative flow section. This will happen when user make different decisions that will lead to different behavior. Another important use case is access student mental status. It is described as administrator staff. They shall be able to access student mental status to understand and support students. The actor is administrator staff, where the post condition is staff have an active and authorized account, and the system must have up-to-date student mental health data. The flow of event includes accessing the dashboard, viewing students' mental health status, and generating summaries based on questionnaires or interviews. Key post conditions ensure all actions are logged for security and audit purpose. Alternative flow handles scenarios such as unauthorized access, which the system blocks or the administrator leaving the page, ensuring no sensitive data remains accessible. The exception flow manages system errors, such as failure to generate summaries, by notifying the user and prompting retries. Noted that each flows, including the flow of event, have its own post conditions. In this activity diagram, we can observe the action performed by each entity or site involved. Additionally, it highlights how different choices lead to a distinct workflow. For example, if the staff choose to mark a student, they must assign a serious status to that student. Alternatively, they can proceed directly to generating a summary or analysis without marking. In this sequence diagram for accessing student mental status, we can observe the return data represented by dashed line arrows. For instance, it shows the student status but being retrieved from the database and sent to the system, as well as the summary being displayed from the system to the authorized staff. This visualization helps us understand the interaction between the actors and the system components. In our report, we include additional use cases that provide various features for the users. This was just a demonstration of how a specific use case operates and how the accompanying diagram functions. Feel free to explore more detail in our report. Thank you.
Hi, I'm Chiu Heng. So now I'm gonna present you the specific requirement of performance. The first one, we got a response time. Basically, the system might respond the user request within 3 seconds under the normal condition without congestion. The second one is the throughput. So the system should be capable of handling 1,000 concurrent users without degradation the performance. So the third one is capacity. The system must support maximum of 50,000 registered users and process up to 10,000 data transactions daily. The fourth one is availability. The system should ensure 99.9% uptime. So the maintenance downtime only can be scheduled outside the peak usage hour. So the next one is about the specific requirement about system attributes. The first one is usability. So the system must provide the user-friendly interface for students. The second one is reliability. The system should be fewer errors and function correctly, consistently across all use cases. The third one is maintainability. So the system architecture should support easy update and enhancement. The fourth one is portability. So this system should be operate seamlessly on various platforms, such as Windows, Macs, Android and iOS. This is the most basic one. The fifth one is the compatibility. The system should be can integrate with the existing campus system. So the sixth one is security. The system should be comply with PDPA and AES 256. The seventh is safety. So this system should ensure the sensitive information such as high risk mental health case is security stored. The eighth one is legal and regulatory compliance. The system must comply with laws governing mental health service and data protection. So now this is the design constraint. Environmental constraint tell that this system should functionally well in indoor condition. The hardware constraint tells us that the device with at least 4 GB of RAM should be run this system very well. The security constraint is about this kind of act. The compatibility constraints tell us that the system should be compatible with widely used browser. The performance constraints tell us that the system should scale dynamically to accommodate peak usage during exam periods.
That's all from the team foreman. Thank you for spending your time to watching our video.